Hey everyone. Today we're going to learn about probability distribution tables, and it is just a little bit of an extension on probability because just asking what's the probability of 2 heads or like 3 tails or whatever, those aren't the only kinds of questions you can ask when you're dealing with probability. For instance, let's say I have 2 dice here, okay? You could ask yourself, if I roll them, what is the most likely sum? So here I have a sum of 7. Great. If I roll them again, there's a sum of 11. Great. And I could keep doing this, a sum of 9, etc. But that won't really help me answer my question of what is the most likely sum that I could have. So this is where these things called probability distribution tables come into play. So watch, I'll build one on the board for you. Okay, so at first, the very first thing I'm going to do is just get a list of all the possible sums, okay? That's what you'll always do when you're building these probability distribution tables. So, let's see. The smallest sum I could have is if I have double ones, right? That's 2, a sum of 2. And the largest sum I could have is a sum of 12, right? If I have double 6s. So, the possible sums I'll put over here. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay? Can you see that? Oh yeah, you can. Good. All right. So those are all the possible sums. Now, which one is the most likely? Which one has the highest probability? Well, this is why I make a table. When you make these probability distribution tables, When you make these probability distribution tables, this column is always going to be probability. This column will always be whatever you're looking at. Like if you're looking at sums, it'll be all the sums. If you're looking at like a number of tails, like if you're flipping 3 coins or something, it would be all the possible number of tails, okay? Now, how the heck do you get the probability of a sum of 2 and a sum of 3 and a sum of 4, etc.? Well, hold on just a second. If I need the probability, it's really good to get a sample space, right? So you already have done this, folks, on the sheet that we did last class. Back side of it, you filled out the sample space chart for 2 dice. So this here is like when you roll a 1, 1, this is a 3, 3, here's a 3, 5, okay? So that's how you read these. So I can use this thing now to fill out, hold on, moving the rolly desk, to fill out these probabilities here, okay? So right here, I need what's the probability that my sum is a 2? Okay, so if I go over here, all I have to do is find, out of all these 36 possibilities, how many of them have a sum of 2? So I'll let you think about that for like 1 second here, okay? There's only 1. If you get double ones, 1 plus 1 is 2, that's the only way to get a sum of 2. So the probability of a sum of 2 is just 1/36. So I will go to my table here and I will write it in. This is 1/36. Okay? Now, what about the probability of a sum of 3? Some of you may already be guessing, but if you don't see it, let me just help you out here. Now I need to look at these combinations and say, okay, how many of them add up to 3? So none of these down here, these are all way over 3, right? But if I move up closer and closer to this corner, I can see I've got 2, 1 and 1, 2. Those add up to 3. And you can go ahead and look, but you're not going to find any others. So what's the probability of a sum of 3? It'd be 2/36. Okay? So if I go over here, I can now fill out for 3, it's 2/36. And I just keep doing that, okay? Next time I'll look for a sum of 4, then I'll look for a sum of 5, and I'll write down the probabilities for all those, and you will get a list of all the probabilities. Can I say one thing, actually, before I sign off here? what do you think the probability of a sum of 12 is, even without looking at the table? If you guessed there's only 1/36 of a probability of that happening, you're right, because it's just double sixes, right? Double sixes is the only way you can get a sum of 12. There's only one double six over there, so this is 1/36, okay? And you can fill out all the rest of these. I happen to know what they are here, so I think I'm just gonna finish them. This is 436, 536, 636, 536, 436. Okay. I know I said I was going to sign off, but I realized I didn't actually answer the question. The reason these probability distribution tables are good is because they help you answer these kinds of questions. What's the most likely sum? Well, you tell me which one of these is the biggest number. You don't get bigger in this table than 636. So if you have six-sided die, like I've got right here, the most likely sum is 7, okay? And you did that by building a probability distribution table. So to review, when you do one of these things, this side here is always the number of outcomes or a list of the outcomes that are possible, okay? And this side here will always be the probability of those outcomes. And then you just fill it in. Hope that helps. Thanks.